Alright, these are our notes for graphs of quadratics, and the first thing we're going to do is review a little bit about what makes a quadratic function. So in order to be a quadratic function, what has to happen in the equation is that the highest exponent must be a 2. It must be a square. So I'm going to give you 3 examples of functions that are all quadratic functions. Each one's a little different. First one is y equals x squared. That's a quadratic function because the highest exponent in the problem on the variable is a square. It's on the x. Here's another one, y equals 4 minus x squared. Also a quadratic for the same reason. And then the third one, y equals 3x plus 6 plus 2x squared. Again, for the same reason, it's a quadratic on all 3 of these because the biggest exponent, the highest exponent, is a 2. It's a square. Now, the general shape of a quadratic is called a parabola, and it's a U shape. It's rounded, and parabolas can open up or they can open down when they're a quadratic function. If a parabola opens left and right, it's not a quadratic function anymore. There would be something different about the equation, and we will get to that eventually. But for what we're doing about for graphs of quadratics today, you need to know that the highest exponent should be a 2, and when that highest exponent is a 2, the graph, the shape of the graph, is called a parabola, and it makes this U shape. Now we can have 3 different forms of quadratic functions. Each one's a little different. Some of them would require some work to show an x squared, but it's there. You would just need to FOIL it to get it to that point. So I'm going to show you each form. First form is standard form, y equals ax squared plus bx plus c. Each one of these terms has a name. This first one is the quadratic term. The reason it's called the quadratic term is because it's got the x squared on it. That's the term that makes the function a quadratic function. It's got the square on that term. The bx is called the linear term. The reason it's called the linear term is because if we didn't have the ax squared and the only thing we had was the bx, it would be a different variation with different variables of slope-intercept form, y equals mx plus b. So that's why it's called the linear term. If we didn't have the quadratic term, then we would have a line. And c is called the constant term. The reason it's the constant term is because it doesn't have a variable on it. That's never going to change. No matter what x is, c will never change. It'll always be the same value. Notice that's a quadratic in standard form because the biggest exponent is a 2. The next one is vertex form. Y equals, a is outside this set of parentheses, x minus h squared plus k. Now we'll get to what these variables mean in a second. This one doesn't have special names for the terms, but it does have a square on that set of parentheses, and we've already learned that if you have a binomial squared, you write it out twice and you would FOIL it, and when you FOIL it, you use the double distributive property, you end up getting an x squared term. So on that, if we would work it out, we would get an x squared term in our problem. So that's one of the reasons. Even though it doesn't look quite like a quadratic, it does have an exponent of 2. And the third one is factored form. Y equals a times x minus m times x minus n. And this is a little different. We're not going to focus on this one today, but again, if you would FOIL the x minus m and the x minus n, you would end up getting a x squared, a quadratic term. So vertex form and standard form are variations of standard form. You would just need to do a little work in order to get them to standard form. This video is going to focus on the first two, standard form and vertex form. And we're going to talk about how to find different things based on those two forms and how to graph based off those two forms. So the first thing we're going to do is look at some general information. And this applies to both of the forms that we're going to look at today. Okay? Parabolas can open up and down, and I said that earlier. How we can tell if they open up or down is we look at the a value. So here's an example of a parabola opening up. Here's one of a parabola opening down. We look at the a value. If that a value on either form is greater than 0, our parabola is going to open up. If that a value is less than 0, or negative, that's what less than 0 means, it's going to open down. So this is if a is positive, and this is if a is negative. Now if a is 0, 0 times anything would cancel the term out. We wouldn't have a quadratic term anymore. So then we would have a linear function, because we would just have bx plus c. So we have to have an a, and if a is positive, the parabola opens up. If a is negative, the parabola opens down. Now, if the parabola opens up, we end up having a minimum value. And if the parabola opens down, we end up having a maximum value. What that means, the minimum value is just the lowest point. We have a low point. And the max means we have a high point. That makes sense because it's a turning point where the graph changes, and the graph's not going to go any higher or lower than that point. So minimum value again means low point. That happens if the parabola opens up. And a maximum value means we have a high point. That happens when the parabola opens down. Now that minimum and maximum value has a special name. It's called the vertex. Alright, and we'll go through how to find the vertex here in a little bit, but that high point or that low point is called the vertex of the parabola. Now the axis of symmetry is where the vertex, we'll get to, it applies to the vertex. If we look at our picture here, the axis of symmetry, let me give you the definition, divides a parabola into two equal halves. Okay, so we have a left side and a right side, and they're identical. What that means, what this axis of symmetry means, we abbreviate it AOS a lot of the time. In our picture, it's this dashed line. What it means, and see if I have this point here on the right-hand side, from my vertex, I would go 2 over and 3 up. That means I have an identical matching point on the other side. So I would go 2 to the left, and then 3 up, and I have a matching point on the other side. This is helpful when you graph. If you know the axis of symmetry and you know where it's at, then you can just match up. You really only need to graph one half of the parabola, and you can find corresponding points on the other half. But that's what the axis of symmetry does. It divides the parabola into two equal halves. And it intersects the parabola at the vertex. So the vertex is where the AOS crosses the parabola. So it's got two different definitions there. The axis of symmetry divides the parabola into two equal halves, and then the vertex is that max-min value, and it's where the axis of symmetry crosses the parabola. Now we're going to look at how to find or calculate the axis of symmetry and the vertex, and this depends on the form you have. Alright, we're going to start with vertex form because it's easier. In vertex form, we can just pull this information out of the formula, which is nice. We just have one little thing to remember, and it regards one of our variables. Alright, so let's review real quick. Remember, A is greater, means it opens up. A is less than, opens down. And that's that first term right here, and it should be a variable. Okay, and it'll be a number. If it's not there, it's understood to be a 1. So again, that's how you tell if it opens up or down. Now to find the axis of symmetry, it's an equation of a line. It's going to be x equals because it's a vertical line. Vertical lines always start out x equals a number. In this case, it's just whatever h is. X equals h. But we need to remember to change the sign of h. If we look in our formula here, y equals a times x minus h squared plus k, it's negative in our formula, and when we write the equation, it's positive. So we want to make sure we change that sign. If it were positive in the formula, when we plug in when we have a number in there, then we would change it and we'd make it a negative. And this will make more sense when we do an example. Just remember to change the sign. The vertex is also easy to find. The vertex is just hk, and those will both be values in the problem. But again, h needs to change its sign. K does not, but h changes its sign. Okay, so it should be the same value for h that you had in your axis of symmetry, which makes sense because the axis of symmetry crosses the parabola at the vertex. The vertex is on that axis of symmetry, so its x value, where its ordered pair, should be the same as that h value. Okay, so vertex form, again, very easy. You're just pulling information out of the problem. Standard form has more work to it, and it's a formula that you're going to need to remember to find your axis of symmetry. Now again, the A tells you whether it opens up or down. and you should be looking at that. And A, B, and C in our problems will all be values. They'll have coefficients on them with the variables. So we need to be pulling just those values out. The x and the x squared will not get pulled out when we use this formula. So let's start with the axis of symmetry. To find the axis of symmetry, we use the formula x equals, again it's a vertical line, so it needs to be x equals negative b over 2a. So we just pull out coefficients and plug them into the problem, or into the formula. So pull the coefficients from the problem. So whatever the b value is, we're going to change it, make it negative. So it's the opposite of b. That's a better way of thinking about it. The opposite of b over 2a. So if b were negative, the opposite of b would be a positive. And again, this will make more sense when we do an example. Now the vertex, similar to how we had the same x value, it's still on in vertex form. The h's were the same. The vertex is the same idea. In a standard form, it has to be on that axis of symmetry. So for its ordered pair, I'm going to write this several different ways. Vertex, the x part of the vertex needs to be negative b over 2a, the opposite of b over 2a. The second part, we take that x value and we plug it into the formula, back into the problem, and we get an answer. So I'm going to write this differently, a second way. Okay, so you get two different ways of thinking about it. First one, the opposite of b over 2a, that's the axis of symmetry formula, and then we take that axis of symmetry value, whatever that number was, and we plug it back into the function, and we evaluate it, and that's what we have, f of negative b over 2a. We would take that answer, plug it in, and whatever answer we get, that would be our y-coordinate. I've also written the axis of symmetry and then the answer you get when you plug back in. I'll write it out in steps as well. So you find the AOS, and then you plug the AOS in to get an answer. Okay, and that's how this one relates to it. Another way of thinking about the vertex, and this might help you too, is the x part is where is it falling. Okay, how far left, how far right is that vertex going to be, and then the y is how high or how low it is. Okay, so all of those are different ways of thinking about the vertex in standard form. You just need to know how to find it at this point. First you do is find the axis of symmetry, and then you take the axis of symmetry, plug it in to get an answer. We're going to look at two examples. Okay, let's read the directions here. It says state whether the parabola opens up or down, has a max or min, give the axis of symmetry, and then the vertex. So we've got four things we need to do here. We're going to start with vertex form. Our problem is y equals negative 3 times x plus 2 squared minus 3. So first thing we want to do is decide if this opens up or down. We look at the a value. Well, here a is negative, it's negative 3. That tells us the parabola opens down. Remember, if a is less than 0, it opens down. When it opens down, it's going to have a max value. It's going to have a high point. So there's the first two parts. We can just tell that by looking at the equation. It opens down because a is negative 3. Since it opens down, it has a max value. In vertex form, it's very easy to find the axis of symmetry. Remember, it's the h value, and we need to change its sign. So if we look in our problem, h is positive 2, so our axis of symmetry is going to be x is negative 2, because we changed the sign from what it is in the problem. The vertex is hk, and again, h needs to change its sign if you're pulling it out of the problem. It should be the same value as the axis of symmetry. So we have negative 2 for our h, and then our k value is negative 3, and there's our vertex. So nothing was too difficult about that. We didn't have to really do any work. We're just pulling information from the problem and interpreting what we see. In standard form, it's a little different. In standard form, we will have to use a formula. So the first thing we're going to do is decide whether it opens up or down. We look at that a value. In this case, a is 2. It's a positive number. That tells us this parabola opens up, and when the parabola opens up, it has a minimum value. It's going to have a low point. The second thing we need to do is find the axis of symmetry, and we use the formula negative b over 2a. So we need to figure out what b is. In this case, b is negative 8, and a is 2. So we're going to plug those into our formula. X equals a negative 8. This is where thinking of the opposite of the number might come in handy, times 2 times a. And a in this case is 2. So this ends up becoming 8 over 4, which is 2. So our axis of symmetry is x equals 2. Again, you might think of that negative b over 2a as the opposite of b over 2a, and you're just plugging in those coefficients from the problem. The x's do not come with those values. The last thing we have to do is find the vertex. And to find the vertex, we plug in the axis of symmetry to the original problem, and we get an answer. And then we write that as the axis of symmetry in the answer. So I know the first part of my vertex is already going to be a 2, because it's the axis of symmetry. Now we're going to plug that 2 into the original problem, and this is where you will need to remember your order of operations. We need to start with the exponents. Okay, so every place I've seen an x, I've plugged a 2 in its place, and now we're going to evaluate this. 2 times, which is now 4 because 2 squared is 4, minus 8 times 2 is 16, plus 6. 4 times 2 is 8, so now I have 8 minus 16 plus 6, and we need to evaluate what that is. Well, 8 minus 16 is negative 8, and plus 6 would be negative 2. So our vertex is 2, negative 2. Again, to find that, we took the axis of symmetry, substituted it back in every place we saw an x, and then evaluated what that expression became and got the answer, and then the answer was the y part of our vertex. 2 more things to look at. The next one is determining the y-intercept of a function, of a quadratic function. And it depends on the form again, and this one is flipped. We said that vertex form was easier for pulling out the axis of symmetry in the vertex, and standard form was more difficult. Here it's the opposite. Vertex form, you're going to have to do more work on this one, and we're going to use the same 2 examples. In vertex form, to find the axis of symmetry, or not the axis of symmetry, the y-intercept, you plug 0 in for x. And the reason we plug 0 in for x is because the y-intercept is always 0 and a number. So our x value has to be 0. That point's not moving left and right, it's only moving up and down. So the x value will always be 0. So if we look at our problem here, I'm going to substitute a 0 in for x, and then we just evaluate this. Well, 0 plus 2 is 2, so we end up getting negative 3 times 2 squared minus 3. You need to do your exponent first. So negative 3 times 4 now, because 2 squared is 4, minus 3. Negative 3 times 4 is negative 12, minus 3. We end up getting negative 15 as our y-intercept. And we should write that as an ordered pair, 0, negative 15. So again, to find it in vertex form, we need to substitute in a 0 for the x, because that point's x-coordinate will always be a 0 since it never moves left and right. Standard form, you could do the same thing. You could plug a 0 in for your x's, but what's nice about standard form is since we have so many x's in our problem, and they just cancel each other out. 0 squared is 0, times 2 would be 0. 8 times 0 is 0. So all we're left with is this constant. So this is why standard form is easier here. It's always 0c. Because the zeros, when we substitute them in, will cancel out our quadratic term, and it'll cancel out our linear term. Cancels out the a, cancels out the b, and all that's left is the c. So here, again, standard form is easier to use on this problem because everything just cancels. But you could think of it just like you do the vertex form, where you're substituting a 0 in for x. Last thing we're going to look at is writing an equation from a vertex and a point. Now, you need to read the directions on these, because if they ask it for it in standard form, you will need to do more work. We're going to find an equation in vertex form every time, and I'll show you how to change vertex form to standard form in this problem. If they don't specify, writing it in vertex form is fine. You can leave it that way. But if they do specify that they want it in standard form, you'll need to do a little more work. So there's 3 steps to this. First step is to plug in your h, k, x, and y values. They're going to give you the vertex, which again is hk, and a point, which we're just going to make xy, because that's what points are, xy coordinates. So they'll give you 4 values that you can plug into the problem. That means the only value left from our formula in vertex form would be the a. So step 2 is to solve for a. And then step 3, and this is where it's similar to slope-intercept form, when you have to find b, you need to rewrite the problem with an a, an h, and a k value. X and y stay variables when you rewrite it. The reason they stay variables when you rewrite it is because we need an equation, something that's graphable. If we put numbers in for everything, it just becomes an equation where one side equals the other. Everything would become a number. We need to have 2 variables in the problem in order to graph it on a coordinate plane. So again, that's why x and y stay variables. So let's look at our example. Hopefully this will make sense when we do this. It's really not that difficult. It's just knowing how to do your math facts in order of operations. It says write an equation for the quadratic if the parabola has a vertex of 1, 2, and passes through the point 3, 4. So they give us these 2 pieces of information. 1, 2, 3, 4. Vertex, again, is hk, and the point is going to be xy. So we're going to start with standard form. And we are just going to, vertex form. We're using vertex form. Start with vertex form, and we're plugging in these values. Well, our y value is 4. We're going to eventually find a. X was 3. Now, here, I'm just going to plug h in. It's minus 1. I don't need to change its sign or anything. Leave the negative, but then just plug the value in. If it happens to be a double negative, just remember that that becomes a positive. It becomes addition. Squared plus 2. So we just do our order of operations here. First thing we want to do is simplify the parentheses. Well, 3 minus 1 is 2, squared, with the a out in front, plus 2, that equals 4. Next thing I want to do is square that 2. So we end up getting 4a plus 2 equals 4. Let's subtract 2 from both sides. Now it's an easy algebra problem. 4 minus 2 is 2, equals 4a, divide by 4. So a is 1/2. That's the end of step 2. We found a. Last thing we got to do is rewrite this. And again, when we rewrite it, x and y stay variables. So it needs to be y equals, we found our a value to be 1/2. X needs to stay a variable. Minus 1. Again, that sign is not going to change. It's just going to be minus whatever your x value was. And then again, if it's a double negative, you would just change it to addition. Squared, it's important you remember that square because that's what makes it the quadratic. Plus, okay, so plus 2. And that would be an acceptable answer. If it just asks you to write an equation, you did. You wrote one, you just wrote it in vertex form. If they ask you to write it in standard form, we need to take this an extra step. So I'm going to start. I'm going to show you how to do this real quick. I'm going to rewrite the problem. And we've talked about this exponent. That's important in this problem because that's where I will see mistakes. I have a binomial squared. And the first thing I want to do with my order of operations is get rid of the exponents. So we're going to get rid of that binomial squared. If you remember, binomial squared means we write it out twice and then we FOIL it. I leave my 1/2 out in front and I leave my plus 2 at the end. Those things will come into play later, but right now we're getting rid of that binomial squared. So we have x times x, which is x squared. X times negative 1 is minus x. Negative 1 times x is minus x. 1 times 1 would be plus 1. That's all in parentheses still, with the 1/2 out in front. That 1/2 goes to that whole group of things. So we'll distribute it after we combine our like terms. And then this 2 will combine after we distribute the half through. We've got to do our order of operations here, which can kind of get tricky and get things. If you get things in the wrong order, you're going to get a completely different answer. So next thing we're going to do is combine like terms. To combine like terms, the negative x's would combine. So we have 1/2 x squared minus 2x plus 1. Again, negative x minus x doesn't become negative x squared. We're just changing the coefficient. I had negative 1, and I have another negative 1. Together I have negative 2. So let's distribute this half through now. We have 1/2 x squared minus 2x plus 1/2, because 1/2 times 1 would be 1/2, and then plus 2 at the end. Now we can combine these two at the end, and we get our final answer. Y equals 1/2 x squared minus 2x plus, and I could write it 2.5. I'm going to write it 2.5. And that would be the answer to our problem. Again, on a problem where they ask you to write the equation, it's important you read the directions, because if they don't specify writing it in vertex form, perfectly acceptable. But if they specify to write it in standard form, you need to go through all of this extra work, FOIL that binomial squared, distribute your a through, and then add k to the problem in order to get an equation in standard form. Those are your notes on graphs of quadratics. Things that you need to take from this video are how to find the vertex and what the vertex is, how to find the axis of symmetry and what the axis of symmetry is. You also need to be able to tell how a parabola, or whether a parabola opens up or down, and identify the coefficients on the terms in standard form, that the a goes with the quadratic term, the b goes with the linear term, and the c is the constant. And then you need to be able to write an equation in either form, vertex or standard form, given a point and the vertex. If you have any questions, rewatch this video or bring them to class next time.